Hello and welcome to RecyclerView Animations, Layout, and more. I am Chet Haase from the Android UI Toolkit Team.
I'm Boyar, also from the UI Toolkit Team.
I would like to point out that that's Yeet, not Yigit or Yigit, which we've heard a lot. If you spelled GIF with that kind of G, it would actually be if. Unconditionally.
I'll use this one.
So I wanted to point out that, first of all, we created a talk to do in 45 minutes, and we figure the amount of material we're covering is about 2 hours worth. So if people are actually watching this as a video instead, if you could just run it at like 2 or 2.5x, then maybe we can cram it all in time. Otherwise, we'll see how we do live.
They should run it half x.
That's too complicated. So I also wanted to point out that we intend today to talk a little bit about architecture of RecyclerView, how the different classes work together to produce animations and to create everything that RecyclerView is. But the thing that we're aiming for with RecyclerView overall, especially when compared to ListView, is to give you a lot of this stuff for free. Right? So it's flexible, it's pluggable, it's customizable, but ideally you will not have to understand the details, some of the details that we're going to go over today, in order to get the kind of animated behavior you want to. But if you would like to customize that behavior, then hopefully the information we're talking about today will help. OK, so let's start with the components. So this is RecyclerView, and many of you use the adapter, the layout manager, and the item animator. And some advanced users use the item decorations or even the pool. But actually, all the RecyclerView architecture is all based on components. There's like more components that you don't see inside. There's a child helper, which handles all these views coming in and out. The adapter helper, which handles your adapter updates, and the recycler. So let's quickly go through these components and know what they are doing. Layout manager is simple. It's maybe the main component that positions your items. It can be a simple list, it can be a grid, or it can be a segregated grid of items. It depends on the layout manager. RecyclerView does not know about it or doesn't care about it. Scrolling is layout manager's responsibility again. Focus. So part of the focus is handled by the RecyclerView. As you move with a keypad, it knows how to move. But if the user reaches the end of the list, or if the layout manager wants to handle separately and user pushes down, now this is layout manager's responsibility to move the other items up and bring a new view and now focus into it. Another example, accessibility. So layout managers provide basic accessibility to information to RecyclerView. So it's like it's this row, this column, or this row, this column. But if you have more information about those views, like the section 1 cannot be accessible to focus, you add an accessibility delegate to your RecyclerView to add this additional information. Let's go back to adapter. So adapter is the one that creates your views, binds the view holders, and tells RecyclerView when the data changes. It's also the place if you want to handle like click listeners, you have multiple view types, or there's some recycle recovery we'll touch later on, and the granular data change events like notify this item has changed, not that the whole list changed. And the important part about adapter is understanding the view holder. Like this is the main component. So I want to go through how we create a view holder. Layout manager at the part of while we run the layout says, OK, give me this view for position X. RecyclerView checks the cache. Do we have the view? Yes, we have the view. Give it back to the layout manager. We didn't even touch the adapter. The first time, of course, the cache says, no, I don't have this view. RecyclerView goes and asks, OK, what type is this view at this position? Tells the position, checks the pool. Do I have a type of this view so I can reuse? If the pool says no, now it goes to the adapter, says, create me a new one of this type. It's not created per position like in the list view. It's created for this type. And the adapter creates that view. If the pool already has it, or adapter creates a new one, just binds it back and returns it to the layout manager. And then the layout manager will eventually add that view to the UI. That's when you get this onView attached to window callback in your adapter. So if you have anything about lifecycle, that's where you're looking for. So how do we reserve a view holder? It's pretty much like we don't need this anymore, but we might need it in the future. So layout manager says, OK, remove and recycle this view. Tells the adapter, OK, this view has been detached. And then checks if this view is valid. This is important. The valid means the view still represents that item in that position. The contents are up to date. but layout manager doesn't want this view anyway. It's like simple example is scrolling. If it is valid, we'll actually move it to the cache from where we can bring it back without doing any operation. And the cache will invalidate the oldest one, and it's going to tell the adapter, OK, this view holder is now recycled. If a view is not invalid, and it will directly go to the pool, and the adapter will receive only recycled callback. It's very important because this is when you don't receive view recycled, people get confused. Cache is important, it helps with performance. Another better way to go to reserves is RecyclerView is doing a layout, tells the layout manager to lay out all the children. And after the layout is complete, RecyclerView checks, OK, which are the children that were laid out before and they don't exist anymore. For each this child, RecyclerView adds them back to the view group. This is the distinction between a view being a child of layout manager versus a child of RecyclerView. And now hides them from the layout manager. This means these views, which layout manager didn't want anymore, they are still a child of the view group, but layout manager doesn't see them. And RecyclerView's abstraction handles this distinguishing. So comes back to RecyclerView. RecyclerView tells the item animator, OK, I have this view. Can you get rid of this? Item animator runs the animation, maybe comes back in 300 milliseconds later, tells the RecyclerView, I'm done with this view. During that animation, this view is not visible to the layout manager's API. RecyclerView tells that, OK, now I'm detaching the view, caches or sends it to the pool. OK, another important about how do we lose a view holder. So layout manager calls remove RecyclerView, RecyclerView checks if it is valid, is not valid. We try to send it to the pool, but we check if it is a transient state. Transient state means it's being animated, like some view properties are being animated. Then the pools asks the adapter, OK, I cannot recycle this view because it's a transient state. In your adapter, you should be overriding this callback and handle it properly, which means get rid of the animation. But maybe you get rid of it in your own bind call. In that case, you can just say, it's fine, just recycle it. I know how to handle it. If you don't do anything, and if the view is in this case, actually, the default implementation says, I don't know how to handle it, and is going to be thrown out. We'll lose that view. Bad. The moral of the story is you should use item animator to animate, which Chet will explain you soon, right? Right, Chet?
Sure.
We'll see if you have time. OK. So another case is RecyclerView says, add view to the pool. The pool says, OK, I have too many of these views at type X. And when that's the case, it says, no, I don't want to recycle it because I already have 5 of it. And then we kill the view. You don't want this to happen. So why would this happen is basically you just have too many of view holders at the same time. We already have it. Why would we? And why would we create too many of them? Why did it create instead of using the existing one? Well, a common case, this happens where you're animating too many of your views through cross-rate, which is change animations. And I want to show this here because I have seen this online. Don't do this. Don't tell the adapter all of your items from 0 to 1,000 has been changed. RecyclerView won't be able to reuse any of those views. We'll get many of them and get to instead of, so how do we fix this? Proper way to fix this is tell RecyclerView which item has changed, or if you really, really need those view types, change the default cache size so that RecyclerView will pull more of them. Item decorations are your just regular drawing elements throughout the canvas, and they can actually add margins or offsets to the view bounds. So let's look at an example. This can be simple item decoration where we draw a round ring around the view. Let's see the API a little bit in detail. So this is my view, and those dots, the boundaries of the view by default. And RecyclerView will ask the item animator, OK, do you have any offsets for this item? Which means, do you want to draw around this item? Where you can say, yes. Just extend it because I need some more space. And then when the drawing starts, this is an empty RecyclerView canvas. So RecyclerView will first call, OK, draw whatever you want to draw before the layout manager or the children draws. So we want to draw this gray background. And then the RecyclerView's draw will happen, the children will draw. And after that, we'll call draw over, where you can draw over the children whatever you want. There are some important things that you should know about item decorations. First of all, do not try to access your adapter because we might call it in the middle of a layout. You can still get the items adapter position, but it's tricky. Instead, go with the information in the view holder. Your view holder should keep whatever information that the item decorator needs. And the on-draw rules apply. Don't allocate, because you are being called many times during the drawing cycle. And when you need to get the view holder, you can use this method. OK, this is the pool is where we keep all the remaining views. So this is a recycler view. And every single item is another recycler view. So wouldn't it be cool if all of them came from the pool? This is where you can use a view pool. All right, let's go back to animations.
Yay! Let's animate some stuff. So we thought when we were constructing this talk, we'd talk more generally about how animations work on Android first, and then we get into the specifics on RecyclerView. And then we created a talk that would take 2 days to deliver. So we're just going to assume that everybody knows how animations work, and we're just going to go on and talk about the RecyclerView animations in particular. So first of all, let's take a look at the different kinds of things that can happen in a RecyclerView. So here's a really interesting RecyclerView over there. I want everybody to know that I did this art myself. OK, so we have an add operation. So we're going to tap on this or whatever. We're going to add an item in between the H and the I. And we're going to create this other representation where you see that P element there. The I and the J got shifted down, and the K is no longer in the list. We have a delete operation. So we're going to delete the H element there. And that's going to create this other list. OK, H is gone. I, J, and K got shifted up. And then we have this new element L down at the bottom. Or we may have a change animation where we're going to change the content inside that J item, and it's going to become this other content over there on the right. So all very good and also all very beautiful, right? OK. So let's talk about animations in particular. So those were the different states, like the before and after. But then how do you animate these things? So in the add operation, say, well, we're going to add an item here. How do we actually transition to this new state of the list? What are the animations that need to take place? Well, clearly, there's a new item there. So we have some sort of animation that's going to fade that in or otherwise make it appear in the list. And then we have I and J that shifted. So we could do maybe some simple translation to move those things around in the list. And then we have the item K that no longer exists. So maybe we can do some sort of fade or disappearing animation to make that go away over time. So for the remove operation, similarly, what animations do we run here? Well, first of all, we're going to need to remove that H element that went away. We're going to shift some things around because they moved within the list in the before and the after state. And then we have this new item there that's potentially going to fade in or otherwise transition to be in the list there. And then finally, we have the change animation, where we're going to run some sort of animation to indicate that the contents of that item have changed over time. So it's important to point out that a lot of this stuff just comes baked into RecyclerView and Item Animator and the default layout managers already. And in fact, even if you start to customize, there's still a lot that just comes for free out of the box. So if an item gets removed, we're automatically going to fade it out. If an item gets added, we're automatically going to fade it in. If it's moving around in the before and after state, then we're going to translate it. And if it's changing, we're going to crossfade it, right? We're going to provide the two different views that we then crossfade between. And then the question is, can we actually do better than that? And it turns out we can. So first of all, let's take a look at what an actual list looks like under the covers. So that's what it looks like on the screen to the user. But really, that's a viewport into the overall list of information that exists on and off the screen, right? So you have this virtual list that they're scrolling through. And you can see the items here that are represented that actually exist in some virtual state off screen. So now let's take another look at how these animations might work given the information that we have about the off-screen items there. So here we said, OK, for an addition, we're going to remove that K element. We're going to shift stuff around and add it if it's in the after state over there. But in actual fact, in the virtual list, that K didn't go away. It got shifted off the screen. So that animation, a richer animation of that K element, is to simply shift it or move it off screen to where it would be if we could see whatever parts of the list that are currently off screen. Item removal, similarly, we said, OK, well, we need to fade this thing out, and then we're going to move some stuff over there, and then this L item is going to appear on the screen because it came from somewhere. Well, we potentially know where it came from, right? This is the virtual list where that L didn't just magically appear. Instead, it shifted on screen from where it used to be in the virtual list. And then changes. So these are the different kinds of animations. It's interesting to sort of break it down and say, what are all the possible changes that can happen in this list before and after, and then how do we animate all of them? So persistence is when items are there before and after, whether or not they move. If they don't move at all, nothing to do. If they move around in the list, then you need to move them. Things get added to the list, things get removed from the list, and things get changed. But it gets interesting when you talk about appearance and disappearance, because here, these are the things where, yeah, it got added to the list, but it only got added to the list because it moved on screen from where it actually persisted before the layout change. These are the two types of animations that we call predictive animations. And there's some parts of the API that are around this. So if you see the word predictive, this is what it's about. It's about telling us the information that we need to know where things came from or where they're going to when they appear or disappear from the list. So there are two main things you want to think about when you're trying to customize animations. One is the layout manager. The layout manager is responsible for figuring out where things go. In the context of animations, it's not just where they are, but it's where they came from and where they're going to be after the layout change. And then on the other side is the item animator, and that's responsible for actually running the animations. So on one side, we have the layout manager that figure out where things were and where they're going to be, and then it tabulates all that information, hands it over to the item animator that then takes that information and says, now, how do we animate these things? And we have built-in animations in the system, but then you can customize given that same information from the layout manager in your own system. So on the layout manager side, you have basically three options. Option one is you can use a standard layout manager. We give you a few. We've got linear layout manager, we've got grid layout manager, and staggered grid layout manager. And all of these come with the capabilities we're talking about now. Not just simple item animations, but also predictive item animations. So if you run, we'll see a demo a little bit later, but it actually moves things off screen smoothly or on screen smoothly because it can tell where these things are coming from or going to. Option two is if you want a custom layout manager, that's fine. Knock yourself out. You know how you want to structure your information on the screen. You're going to have a little bit of work to do if you want to go beyond the basics. But basic item animation is handled for you. We know how to fade things in and out and to cross-fade them and to translate on the screen. We can calculate all that stuff automatically. But it's not predictive because we don't know your layout manager, so we can't tell for your staggered grid stacked queue thing that you have on the screen, where should that item have been before we made it appear on the screen in your strange layout manager? We don't know, so all we can do is fade it in. And then option three is to go full bore custom and say, I've got a custom layout manager and I want predictive animations, so you're going to need to enable those. And then you're going to need to tell us what we need to know. For the items that go away, that disappeared off the screen, where would they have gone if we could still see them? Or if they appear on the screen from off screen, where did they come from? So let's take a look at some of this information. How do we get this? So it's the two sides. It's the pre-layout where we're trying to figure out like where they were before they then disappeared, and the post-layout, like, well, where did they go once they disappeared from the list? For everything that's in that list, virtual or non. And so an important element here is that there's potentially two calls to on-layout children. Specifically, if you opt into predictive animations, then you're going to see two calls into your on-layout children method. The first one is going to be pre-layout, where we need to know the information before the layout change happens, including for the items that are going to go away. And then there's the regular layout, where we figure out where everything is once layout is actually already run. All right, so let's take a look at a little bit of code. So we have support predictive item animations. This is what you need to override and return true if you actually want predictive animations. And then we're going to call you twice for on-layout children. And in on-layout children, this code is stolen mostly from linear layout manager, which Yigit wrote. Which I would suggest you look at to understand the basics of how this works. But at a very high level, there's sort of three important elements here. One is first you detach and scrap the view. So you basically say, OK, take everything off, and then I'm going to tell you how to repopulate it into the view. And then we're going to go through all the items that need to be in the list, and we're going to add them in. And then we're going to account for information. If it's removed, then we're going to adjust the layout parameters appropriately. And there's a couple of important things to note here is the item count accounts for not just the real items that are in the list, but if you're being called on pre-layout, it also accounts for the items that are in the list prior to layout running. right? So we want to know where all of the items were before a layout run, including those items that are going to go away because of layout. So you iterate through those, you put them in place, you add all the views to RecyclerView, and then finally you do this step and say, well, if I'm not running pre-layout, then I also need to figure out where the items are going to be in the virtual RecyclerView, in the virtual list after layout runs. So once you've provided all that information, then RecyclerView has the information that it needs to then provide it to the item animator to run the animations. So an item animator, let's have some gratuitous animations. Awesome. So a couple of item options with Item Animator. One is go ahead and use the default Item Animator. That's why we wrote it. It does a lot of the basics for you. If you just want simple animations, RecyclerView basically enables default Item Animator by default. That's why we called it that.
That's clever naming.
Clever naming. We think a lot about APIs on the Android team. Then go ahead and use it. And you could at least start from there and then start customizing as you see fit for some specialized animations. So it does fade out and translate, and it fades in, and it crossfades changes. Option 2 is you can get a little more customized, and you can implement Item Animator directly or implement simple Item Animator, or you can subclass. So what we did in the demo you're about to see is we subclassed off of default Item Animator and then just overrode the specific capabilities that we wanted. So there's a lot of things that you can lean on there so that you don't have to actually do everything. So there's an important step about recording the pre and post layout information. Chances are, if you're doing custom animations, you may want more information than the system records by default. By default, it says what was the view that was changing here, and what were the bounds of that view. So then it knows basically how big it was and where it came from before and after, and it can create some simple animations based on that information. But if you're animating custom content in your view holder, then maybe you want more information recorded before and after. It's worth pointing out that if anybody's taken a look at the transitions or the activity transitions APIs, this is very similar to that. It's the idea that I need to record a bunch of information, then layout is going to run, then I'm going to record information for the same and potentially different views, and then we're going to compare them and run appropriate animations. So we record that stuff before and after, and then you're going to override. You're going to choose which methods to override. So you can animate the appearance or disappearance for things that are appearing or going away, whether they're moving or not. You're going to animate persistence, which is the things that don't move, as well as the things that move on the screen, but basically are there before and after layout runs. And then you're going to animate change when the actual contents in items change. And all of these, as I said, these have standard implementations in default Item Animator, but then you can choose to override and do something custom if you want. And then an important point is that when you're done with your animation on any particular view holder, you have to call dispatch animation finished. There's a little bit of state that's being tracked in some situations that we need to know when to get rid of. So a good example, Yigit alluded to this before, is if you remove a view and then we're going to animate it, we're going to fade that view out, we actually take that view and we add it into the view group so that it can exist so that we can actually fade it out, right? You removed it from the recycler view, but we added it in as kind of a hidden view in the view group just for the purposes of running the animation. Well, we need to know when the animation is done so that we can remove it then.
There's actually like one common bug people see where they play with this RecyclerView count, which is public, unfortunately, and then they see these shadow views on the UI because Layout Manager doesn't see them. So Layout Manager lays out, everything works fine, but there's one of those views that was animating and got stuck there. This is when the proper APIs are not called back or you are mocking up with internals of RecyclerView. So keep that in mind.
And finally, there's an item, if you want to customize the change animation in particular, there's new APIs that came out in, what was that, 23.1? 23.1.1?
23.1.0.
OK, 1.0. Support lib release a few weeks ago with new change animation APIs. And it gives us the ability to not recycle or create a new view holder, sorry, to recycle and not create a new view holder, and we can pass it back to you. This avoids potentially expensive things like layout or just creating all these objects on your behalf. So now, instead of simply cross-fading views for different view holders, we can actually hand you back the same thing, and then you can do a totally custom animation, potentially with lower overhead. OK, so let's take a look at a demo. Fantastic demo. I bet I wrote this. Isn't this beautiful? OK, so we have a simpler recycler view here. You see me flinging. You see me flinging back. There's a linear layout with a background color on it. There's a text view in the middle. The background color determines the value of the text view. It's really complicated. OK, so some of the elements here, standard recycler view, standard default item animator. You haven't seen the animations yet, so that doesn't mean anything. Standard linear layout manager with one caveat that I wanted to disable predictive animations so that we could talk about some of the artifacts that you'll see if you do not have predictive animations enabled. But linear layout manager actually has them enabled by default. So yay. All right, so there's a simple view holder here. It's just retaining information about the text view and the linear layout so that it can get those later and set the color and the text appropriately or even animate those values. Simple adapter. So we have this adapter. We're going to be called to bind the view holder with the appropriate information. We have this database, very complicated architecture here. We have a list of colors here, and we're going to bind the background color of the container and the text in the text view appropriately. And then we're going to be called to create a view holder. We inflate this resource. We're going to set a click listener, because that's how I determine where these things are going to be added and deleted in this awesome demo that we're working through right now. And that's really about it in the basic recycler view. And then we're just going to get some default behavior for the delete and the add animations, so we can see the delete here. You can see the touch point, the little white circle. We're clicking on items there, and we're deleting those. And we fade the thing out that got deleted. We shift stuff up that got moved in the recycler view before and after. And then we fade in a new item at the bottom. The delete operation is very simple. We remove it from the list that we had of the appropriate position there. And then we do a notify item removed. It's important to tell RecyclerView the thing that happened. Don't just say, something changed. The more information you give us about the specific range, the specific item, the specific action, the better able we are going to be to actually take advantage of that and give you a richer experience. If you just say something changed and we don't have stable IDs and can't determine what those things are that changed, you're probably not going to get the rich animations and interaction that you want. OK, so let's take a look at add animations. Once again, we're going to click an item there, and then we're going to add one into the middle of the list. We're going to fade the thing out at the bottom that's going away. We're going to shift some things on the screen. Then we're going to fade in the new item there. Decent animations, but I think we can do better. This is very similar to the delete thing, where instead of calling notify delete, we do a notify item inserted after we've added the color into the list. All right, so here are the artifacts that I was talking about, so you can sort of see these delete and add operations again. And you can see that instead of, this is supposed to be a contiguous list, right? You're basically breaking the user's mental model. They think there's a list, but then why is there that weird janky thing at the bottom where things are fading in and out? Now it doesn't look like a list. It just looks like a jumble of items there, right? So that's the thing that we want to get around with predictive animations. So if we take a look at predictive animations for the fade case, you can see that now when items go away, they move off the screen very logically into the position that they're still occupying within the virtual list. Same thing with delete. When items come in from off screen, they're moving in a very predictable manner that matches what the user thinks about this list structure. So some code to enable this. First of all, here's my awesome linear layout manager custom class where it basically just enables or disables predictive animations just for the purposes of running this demo.
Open source it.
Yeah, we're going to open source just that one snippet of code. That's really the most interesting bit in the entire demo. We're looking into open sourcing the rest of it, but that's the one that I really want to get out there. Maybe we can write an article on my blog about that. Medium.com will write an article about that snippet. Check there. OK, so default change animations, you can see as we click it, you get a crossfade, right? We're doing a crossfade of the background color as well as the text. Everything all at the same time. Basically, we have the old view, we have the new view, and we simply do an alpha crossfade between them. It's decent, but maybe we can make that a little more interesting. And that's with the standard item default item animator. So with a custom item animator, we've got a little bit something more interesting going on. So instead of crossfading between these two views, we're actually treating the entire view hierarchy in there, the linear layout and the text view separately and doing different things with them. So the background color is fading to black and then back up to the new color. And the text is rotating out of place and then with the new value rotating into place. So how do we do that? First of all, we say that we can reuse the view holder because I don't want to create a new one. I simply want to animate the items that are in the existing view holder that we already have. And then we extend default item animator specifically to customize the change animation. So here we've got the get item holder info. This is the data structure where we cache the information that we're going to retain before and after so that we know the values that we actually need to animate before and after. And then this is going to be called by both the pre-layout record operation as well as the post-layout record. So basically, when you customize this stuff, we're going to call your code and say, OK, record whatever you want before, and now layout is run. Record whatever you want after. And then your animation calls are going to be called with those data structures so that you can then take that information that you recorded earlier and do something with it. So here we override the animate change method. And you can see in the method parameters, we've got the holder, the old holder, and the new holder, which in this case is actually going to be the same view holder information. And we have the pre-info and the post-info. So that's the data structures that we filled in ourselves when we were called before and after. And then let's see how this works. So we create some animations here. We have one animation that does a fade to black from the old color, and then a fade from black into the new color. And we structure that inside an animator set and sequence those to run one after the other. And then the text rotation is on the text view itself. So we're going to do a rotation of 0 to 90 to rotate it so that it's perpendicular to the viewer. And then we swap the text out, we'll see on the next slide. And then we animate the text back into place with the new value of it. And again, we run those sequentially. Animator set, run one, run the other, and we're done. I'm cutting out a little bit of code. There's some interpolators in there, but I just wanted to get the high-level view of what's going on there. And then we add a listener on the animation so that we swap the text appropriately. So we're going to use the old text. So we've already run layout, right? And our reused view holder has the new text in it. Well, that's not going to make any sense if we're trying to rotate the old text out. So when the animation starts, we substitute that with the old text. And then we run that half an animation to rotate it out of view so the viewer can't see it anymore. Then we swap in the value of the new text, and we rotate it into place. Change animation. So now we put all this stuff together. We create an animator set, and we add them all together. And then most importantly, we call dispatch animation finished so that the recycler view can get rid of any state that it retained for these things along the way. And then we're off and running. OK, so on the previous one, if you actually clicked on an item that was animating, you'd get some kind of janky effects because you'd be in the middle of an animation, and then a new animation would start. And they'd both be running at the same time. Or maybe you could cancel one, but you would get some discontinuous behavior. So what I really wanted was if the user just continuously clicks on these things, you make that transition to the new animation as smooth as possible. So you can see we're doing that on the right there. We're clicking on this thing, and it looks mostly good. If they click during the second half, well, there's a little too much information, so we are swapping the text along the way, but we're making the color transition as smooth as possible. So how do we do that? First of all, we need to cache the running animations. We're going to need to retain information about what's actually running on each item so that we can get that information later. So we're going to cache this in this little data structure. And then we're going to check it. When we're told to animate a change, we're going to say, well, are there any animations currently running on this thing? If there are, let's record some information about that. Are we in the first half of the animation or the second half of the animation? And how far are we in those animations? And then we're going to seek the new animation. So we're going to take all that information from what used to be running and then seek in the new animations that we created from the previous code that we saw before, so that if you're halfway through or a quarter of the way through that first half an animation, we're going to seek a quarter of the way through the new animation. So it's going to start at exactly the same place that the old one left off. And then we're going to cache the new animators when we're done, because we need to provide that information for the next interruption that occurs. And that was it.
Thanks, Chet. That was very useful.
You are welcome, Yigit.
I wish I saw them before writing them, but that would be helpful. OK, so we wanted to touch base on like some important things about RecyclerView that we think you should know about. So no update means no on-bind. This is one problem when people transition from ListView and come with the same expectations. RecyclerView is different. So if you don't tell that an item has been updated, we are not going to rebind it. How do you update an item? So for example, if you say item moved, the item only moved. Like I have no idea you are displaying a row number there because you didn't tell me item has changed. So we will just move it. We are not going to tell to the adapter. Why do we do this? Because not calling onBind means we are not invalidating anything. If we don't invalidate anything, caches are valid and kittens are happy. It's important. So another mistake I always see is that making this. You cannot make position final in onBind calls. This goes back to the same example in the previous slide. Just because an item moved doesn't mean we are going to rebind it. So if you use that position in an example like this, like in a click listener, you are doing it wrong. So we can easily crash this code by something like this. You bind it to item position 5, you move it, then call onClick. Now you remove the wrong item from the adapter. So how do we solve this? Oops, I solve. Come here, come here, come here. And one more time. OK, yes, this is how we solve it. There's a get adapter position in the holder, which will always give you the up-to-date adapter position for a holder. So if you cannot use that position, it's better to create that click listener when you create the view holder. So it's much better to use the create view holder to add your callback so that you don't keep creating a new object every time the view is rebounds. And this no position check is also important because in a case where an item is deleted but user is quick enough to click on that item before it is removed from the UI, you will still receive the callback because it's a real view. So you should always check for no position. Another one of the new APIs we introduced is this item payload. So when you change an item, you can say why it changed. For example, I can say this item in this position changed because maybe user liked it or user stopped liking it. The cool part about this API is there's another onBind method which receives a list of payloads. And so if the payload is empty, you just run the regular onBind. But if the payload is not empty, this means we are reusing the same view holder. So you know that view holder was representing the same item before. A change came for this particular reason. So the only thing, so say it's a like update, the only thing you have to do is change that button because you know the rest of the view holder is valid. And this same payload information is also passed to your item animator where you can use to decide, oh, the like change, I'm going to animate the heart. So this is another confusion in RecyclerView where what does an adapter position means a layout position, right? Why can't be that it's only one position? We did it, it was wrong. So let's see this example where we have a bunch of items. The AP stands for adapter position, LP layout position. They're all the same, it matches. Then the adapter says I moved the item at position to item at position 5. So now if you look at it, the items, their adapter position doesn't match their layout positions. RecyclerView knows this. Like if you try to call the adapter, try to get the adapter position on that view, it will tell you it's at 5. So you can safely access your adapter. It's just we didn't run a layout yet. So when the layout runs, items go to their correct positions, and these two are synced again. So that's why, so if you, for example, in an event, you're trying to get the view above the other one, then you would like to use the layout position because that's what the user is seeing at that moment. But if you want to access the adapter, remove or modify, you use the adapter position. So another mistake we have seen a lot is when RecyclerView calls onCreate, that means it needs a new view holder. So it's a common mistake. Oh, I have a header view holder. If RecyclerView asks for it, let me just cache and return it. It told you to create, not to return the existing one. It would use it if it could, right? So you cannot do this. You need to be creating any view holders or get it from some other pool that RecyclerView doesn't know about. So another example. So recycle pools are great. We can reuse the views among different RecyclerViews, even in your own components. So let me create this one giant pool for all of my application so I don't create views again. Yay, performance. No, you cannot do this either because if you do this, first you're going to leak the context. These views are inflated per their context. They get the styles, they inherit a bunch of stuff. So you can, if you leave the activity, the view will keep a reference to the context, that will to the activity, everything will leak, your app will crash. The second problem is the inconsistency because the context may change between activities. They may be loaded with different styles, with different theme. So you cannot do this. You need to create a pool per activity context. OK. So, OK, there's another problem we've been seeing where people adapt RecyclerView if it receives a change animation on a background thread. We generally, well, you cannot do this. You need to update your adapter on a main thread. But people are clever. What do? They is they update their contents on a background thread, then notify the RecyclerView on the main thread. You cannot fool RecyclerView. If there's a, I mean, if that was the proper solution, we would do it, right? Like, so just move it to the main thread. So that's not the problem. The problem is while RecyclerView is calculating a layout, you cannot suddenly say, I just removed item 3. Oh, wait, I was binding it. Like, what happens? You cannot do this. You have to update the adapter on main thread and tell RecyclerView instantly. This is a trick. You update it, tell. Write those methods in your adapter where every time its contents are updated, it tells the RecyclerView. Yay. Oh my God, we're on time.
we actually finished in time. So I did want to point out we will open source the real demo. We just have to figure out how. So check our feeds here if you want to. Those are the wrong links for the Dev Summit at the bottom, I think.
Oops.
Don't ignore the ones on the lower right. They're wrong. But check our Twitter or G+ feeds, and we'll post something when we open source the demo. We have 2 minutes and 50 seconds for questions. Yes. Oh, sorry, there's a mic coming.
Let's wait for a mic.
You want to pass?
All right, and we're out of time. Sorry.
So just want to know, compared with the ListView, is there any performance impact on the RecyclerView?
Compared to ListView, is there any performance impact? I would say hopefully it's all positive. Some of the stuff that you alluded to, like not calling on bind because we have more information about the stuff. We also, because we know the specific items and actions and ranges that are being changed, we can do things more optimally. Our cache is more intelligent.
I think, yeah, one of the biggest UI performance improvements comes from not calling on bind. So if you dispatch proper adapter updates, you will probably gain performance. But of course, RecyclerView runs more animations, handles more cases, so there's a cost of them as well. But I mean, you want those animations probably, so you better use RecyclerView. Important part is dispatch proper adapter updates. So,
Thank you.
Thanks.
another question?
Yes. Oh.
Like,
No. Yes? Who?
he was waiting.
I'm going to be first.
OK.
In your demo, you show the set-on-click listener for every item on every view. With multi-touch screens right now, every item will be clicked simultaneously if you click like multiple items. Any of your suggestions to prevent multi-clicks on RecyclerView?
Actually, the multi-click wouldn't be an issue in general. Like, it's pretty robust. It's just going to execute all of them independently. I don't know why multi-touch would have an impact on that.
Yeah, I'm not sure if I understand
It's just separate click events.
Yes, in terms, on the list view, we had like on item selected. So as long as one item will be notified that it's selected, other one is not going to be like clicked at this moment of time.
This is totally different. These were just click listeners. There was nothing about selection or active items or anything. These were, I mean, maybe you're asking a question that I'm not answering, and that's very convenient of me. But
he does that to me all the time.
but I think it works. There was one other person that had a question, then that's all that we got time for.
Hi, I'm a developer. I'm a professor too. I don't know if it's exactly a feedback or a question. To me, a RecyclerView is a little bit verbalized compared to an iOS table view and etc. We have to write a lot of code to make it happen. And I teach coding to my students, and it's a hard job to them to make a simple RecyclerView. And now you have data binding. So will you have some things to write less code to make a RecyclerView or something like it in the future to make our work building RecyclerView better or
If only the people that wrote RecyclerView had anything to do with the people that wrote data binding.
Coincidence. Okay. So we're trying to solve a problem with RecyclerView, which was mainly animations. And the ListView kind of reaches limits on how much we can flex it, start the breakdown. So the main focus on RecyclerView is to enable you to do weird stuff. And right now it requires more code because we are not focusing on making it easy. We are trying to enable it. After a while, the API, like we just changed the animation API to enable a bunch of stuff. Once the APIs become more stable, we are going to provide more components on top of RecyclerView, but that's not our focus today.
First, get the architecture right, then get everything simpler.
Okay.
And not get us into the ListView situation where it works, but it's terribly fragile. The architecture is not very flexible. So that was the whole point with RecyclerView. I think that's more than the time that we had. Thank you.
Thank you.